everyone doing? Come on, come on. All right. All right, welcome everyone. We're going to talk more AI. It's kind of feeling like an AI conference, which is kind of in my wheelhouse, I guess. Yeah, hopefully, don't tell Mark, but it feels less mixed reality and more AI these days. So it's an honor to be here. I've been in the AI space for a while. And I still remember like the first experience I had. I was walking into a UC Berkeley retreat. Has anyone been to an academic retreat? They have kind of a cool vibe to them. And I was surrounded by like industry players and Google and Yahoo and all these companies, and they were all sitting in the room and they were all like working together. And I'm like, what the hell is going on here? This is crazy. And they were just contributing to open source and fixing things, and it was such an amazing thing that it stuck with me, and I've worked in AI and open source for the last decade as a result, if that tells you anything. And so I'm here representing Llama and the team and the community, and it's such an honor. I've worked on projects like PyTorch, if you're familiar with PyTorch, and Onyx. I've also worked on areas like AI-guided material discovery, protein folding, areas like game theory. So I've kind of hit a spectrum of different areas in my career, and it's really amazing to me that it's all been kind of built on open source, which is, again, what's near and dear to my heart. And so to kind of put it in perspective, and I guess in my perspective, given I've been working about last decade in the space, back in like the 2012, 2013 timeframe, is anyone familiar with the ImageNet moment? Oh my God, okay. All right, so we'll get to that later on. Machine learning was this kind of esoteric, like, deep lab, like academic, top company kind of thing, very, very kind of niche, very elite research. And you can see in this graph here, it's taken a while for ML to become kind of in the general consciousness. In contrast to that, though, if you look at generative AI, you can see in the kind of the red there, it's basically at the same level within 10 months or even less. So it's absolutely wild at how quickly Gen AI is kind of caught on. LLMs are in kind of our mainstream discourse, and it's really interesting how fast this is really accelerated. And there's a reason for that. I think, and that is that we actually are starting to realize the impact of this technology. It's starting to impact areas like education, healthcare, entertainment, and of course experiences like Instagram, which we of course announced yesterday with Mark. So it's really underpinning just about everything that's kind of new and innovative now. And what I'm excited about is that open source and open science actually is really underneath it all. And so I'm going to assume that people have heard of some of the things on this slide. I had the honor of working on PyTorch, which is actually a deep learning framework that allows you to author these algorithms. And it kind of became this lingua franca, this common language, this platform that the community embraced. And it gave us GPT-3, GPT-4, Stable Diffusion. We wouldn't have ChatGPT today if it weren't for PyTorch. So that kind of tells you how this flywheel has created this platform of innovation. But today I want to talk about Llama. And Llama is such an amazing community. It's not just a set of models. It really is this community that is it's really rich and innovative. And I want to just bring you in and kind of give you a little bit of history, where it is today, and where I see it going in the future. All of this through the lens of open source and open science. So if you look at Meta, though, in the history of some of the projects we've been involved with, we've open sourced, Meta is one of those companies, and honestly, why I'm here and why I love being here, the things we do are kind of built to be open by default. So it's not even a question of whether we're going to open source something. It's just a matter of like how and when and how we get the resources and all like the details and such. But by default, we think about things as being open. And I'm especially proud of some of the projects like Opacus, Crypt10, where we've actually bridged ML and privacy, which has actually made a lot of the work, a lot of the products going forward very much safer and much more private. So I want to dive a little bit deeper into how this sausage is made, though. And one thing, if you look back at that graph, of the last 10 years, that workflow has evolved quite a bit. And I'll dive into a little bit of the details on that. But things have definitely changed, and I've seen it firsthand, and it's been kind of fun to witness it. Okay, so no one knows what ImageNet is. Does anyone know hot dog, not hot dog? Okay, a few more people. Okay. So, kind of circa 2012, we kind of discovered that deep neural networks were really good at computer vision. So, prior to that, you had to handcraft features. So if you were looking for a face, for example, you would identify the eyes, and you would craft some features, and you could have like a face detection algorithm. And that required, that shift to deep learning basically allowed the algorithm to actually find those features for you. And that's where you get to the hot dog, not hot dog thing, where you have a classifier that actually can say, okay, that is a hot dog, that is a piece of cheese pizza, whatever it is. But that was really, really an expensive paradigm. It actually required human labeling on every single piece of data. So you had these XY pairs, and it really required you to have just a large-scale annotation workforce. But it was a really powerful moment. We learned that we could train these things at scale, even though it was expensive. And then you fast forward to 2018, we kind of have the year of the transformer. And the transformer is a model architecture that, at the highest level, allows you to train on unlabeled data at incredible scale. And what you could do then is you could then fine-tune on a small amount of your custom data and actually apply this to your application. And at the time, it was really, really expensive to deploy. We just didn't even have the compute. A lot of these models weren't optimized to be deployed at the level of scale that was required for things like language translation. But what it did do is actually give us a new state-of-the-art in areas like translation and document generation and so on. And then you move to 2022, which is really just last year, feels like ancient history now. We brought the human element back into it, and we incorporated something called RLHF. So that stands for Reinforcement Learning with Human Feedback. And what we wanted to do is take basically that paradigm from back in 2018, but align it much more closely with what a human wants. Like, what do we want these models to actually act like? And that's actually given us state-of-the-art assistance, characters, like we have, we're talking about at this conference, even generation of images and videos, and much more aligned in how we want them to be generated. And then you fast forward to present day, the model has essentially become the platform, and which is really interesting, and we're really excited that Llama actually has become that platform. And if you've ever heard the terms, prompt engineering or fine-tuning of models, it's getting easier and easier to basically take these models, incorporate a little bit of what you want them to go do, and then deploy them in an application, and it's incredibly powerful. But the net result of this is we've actually been able to bring in orders of magnitude more developers, orders of magnitude more people into the ecosystem with more diverse thinking, just more diversity in general. And it's really changed the way generative AI and AI in general, the kind of the complexion of this community. So I want to take a step back here and talk a little bit about the history of Llama, because there's actually some really fun little anecdotes of where all this came from. So I know we love to talk about Llama 2, but what about Llama 1? So we had this project that we were working on around formal mathematics. So how do you prove theorems using AI? And we actually, last year, published some work around that. You can check it out. It's on our site. But in parallel, that team, which was largely based in Paris, they started to think about what an LLM would look like that followed the latest scaling laws, had highly curated data, that could be deployed in kind of large-scale research and kind of form a foundation of research. And that was where Llama 1 came from. It was an incredibly fast-moving project. It was a lot of borrowed compute. It wasn't the main thing, right? And that really kind of sparked a lot of innovation, especially in academia. But I think one of the things we wanted to go do is, we wanted to extend and bring this to a broader audience. And that's really where Llama 2 came in. And Llama 2 allows commercial usage. It had different sizes of checkpoints, for example. So the original Llama models were 65 billion parameters, which were quite expensive to, to deploy in an application. And so there's 7B and 13B and 70B, and this kind of gives you a wide range of options depending on what computational resources you have. In addition, we actually released fine-tuned models, and ones that were actually RLHF. I talked about RLHF. These were aligned for chat. And so this kind of gives you kind of the foundation of, you can bring this into any type of application that you want to, any kind of conversational agent. And that's really where we are today with Llama 2. In August, we actually released Code Llama, and Code Llama was built on Llama 2 and basically fine-tuned on additional code. And code is actually, while it's useful for the coding application, asking about code, generating code, it's actually really powerful for reasoning as well. It improves the reasoning of these models. But why did we even do this in the first place? What are our goals? Why are we just giving away all this amazing technology? We do have a reason, actually several. So firstly, if you look at the enterprise and and kind of the commercialization space, we are obviously using the models ourselves. We have a number of use cases, as you saw from Mark's keynote and Ahmad's keynote. But the more we can get this technology into the hands of more folks that are applying them to different use cases, the more we can learn. And I'll talk more about that later on. So, what this allows us to do is really learn, through iteration with these close partners, allows us to learn how to more safely deploy this technology, because we always talk about hallucinations and how is this generative AI, how do we use this in different ways, and how do we get these kind of models to behave in the ways we want them to. And then lastly, all of this really ladders up to how do we build better experiences on Meta, whether that's on Instagram or some of our new characters and our AIs. Ultimately, we want to build the best and most impactful and innovative products and experiences. And so, if you look at the developer ecosystem, so I talked about PyTorch, and one of the things we've had to kind of adjust to with this new generative AI paradigm is LLMs and these really large models have actually changed the way that that models have been manipulated, managed, deployed, like how we evaluate them. Evaluation is actually a completely green field when it comes to research. Obviously, we have safety evals and things, but it's such an open area. And so having, again, something that the community is building on and having that kind of common bridge has really accelerated even our own internal stack. And so if you look at PyTorch and Llama together, it's really a common bridge for us with the community, and we can actually build things together and really grow together. But let's jump into actually some of the metrics. We look at kind of the axes around enterprise, and we look at research and some of the tools, and basically, how well is the community growing? So, starting with GitHub, and start with models. So if you look at the number of models that are coming out on top of Llama, Llama 2 has become basically a platform for others to kind of build on. And today we have over 7,000 derivative models. That means someone has taken the Llama 2 model, downloaded it, fine-tuned it on, say, a different data set, different language, improved it on different benchmarks, and it's actually really raising all boats. On top of that, we have this partner ecosystem around us, all the way from the hardware, all the way through to platforms that engage and allow developers to use Llama, to use it in API form, to fine-tune it. And at the hardware level, this actually allows us to get a lot of scale. These models are expensive for training and inference. And what we've seen is actually our partners like Intel, AMD, Qualcomm, using this as a benchmark target actually helps developers to use these models on different types of platforms like mobile devices, more cheaply and cost effectively on cloud infrastructure and so on. And then for the platform, we just announced obviously the Amazon Bedrock partnership yesterday, which was super amazing. That allows you basically to use Llama in a simple API and then even fine-tune it. And so you don't need to learn any deep learning, you don't need to learn any PyTorch. Basically call a pretty simple API, and you can actually incorporate it very easily into your application. And this is actually it really is a game changer. It's going to allow a step change level of access, for developers, and it brings obviously all the benefits that running on Amazon does. And so, when you look around Llama, so when we released the models themselves, we basically put a GitHub repo out there and access to the weights and said, go off and prosper. But the community has just absolutely embraced the models and actually started to build around them. And so what we've actually seen is, mobile device support, different operating systems. There's even a different language support. So if anybody programs in C#, there's a version for that. But overall, we've just seen the community embrace and actually fill in a lot of the gaps around us and really make this more of a platform. And actually, this has culminated in actual enterprise adoption, which is really amazing. So coming from pure open source, from the framework and the tools, all the way to open models, and now we're actually seeing the fruits of all of this actually manifest in partners like Reliance Jio, Shopify, and Orange. And I met some of the folks in backstage, and they're really, really excited to talk to you later today. But this is what we really wanted. We wanted all of this technology to fundamentally have impact. And we're really excited that our partners are here to talk about it. And then, of course, GitHub. GitHub is the unofficial epicenter of AI development and sharing of code. There's over 7,000 repos now on GitHub that mention or use Llama. And you can see from some of the different types of projects that are on GitHub. The Yarn project, for example, extends the context window to over 100,000 tokens. Llama is a great one. If you're just trying to get started with Llama, Llama actually allows you to run it locally on your Mac device or your MacBook Pro or whatever it is. There's Video Llama. I mentioned Llama Sharp. So it's a really kind of interesting and diverse ecosystem on GitHub that's starting to form. And then the last piece is, it really does take a village to move things forward. And what we've actually seen is by putting our models out there, the community has embraced them and actually improved on some of these common benchmarks. So you can see, on average, close to 10% across these standard benchmarks that basically test how well your model reasons, things like common sense in the case of a HelloSwag. And even if you look at on the far right there, the truthful QA, which basically is a benchmark that mimics human falsehoods, which is kind of an interesting benchmark. The community has actually improved our benchmark, our baseline models by over 46%. So the community, kind of using our models as a base, building on them, and really taking them much, much further forward than we have ourselves, which is just awesome to see. So where does this all go? That's the ultimate question. My boss, Ahmad, yesterday left you hanging. I won't leave you hanging too much, but I will give you kind of a few hints of where things are going. So number one, we are at a mixed reality conference, and you saw the Ray-Ban, the Ray-Ban stories yesterday, and just the world is multimodal. It's not purely a text-to-text, paradigm that we live in. So you're absolutely going to see, things move in different directions going forward. Secondly, safety and responsibility. We red teamed the Llama models to an incredible extent, almost like they're too safe in some cases. But this is something that we believe can be a vehicle for the community to learn about how to build safely and responsibly. And we're just excited that Llama can be that platform. And I think the last piece is community. I think we've learned a lot with PyTorch. I think we've learned that the community wants a voice. The community wants to have agency. And I think this is something that we're going to invest a lot into. And we want Llama to be that platform for them to bring their best, to bring their innovation, and really learn and grow and just help make this an even more open community. Thank you so much.